Hello, um, my name is Dominika Foll. I'm working for the Intel Open Source Technology Center. I'm located in Vannes, in Brittany, in the west of France. We're going to talk today about how to create a profile, a Tizen profile, obviously, from the project Tizen Common. So just to let you know who I am more in details, I've been working for Intel in the open source group for a bit more than 3 years now. And before that, I was working for Amino Communication in Cambridge, UK, as a CTO, and I was the architect of Migo TV. Today, I'm the architect for Tizen Common and Tizen IVI. So let's see what we're going to discuss in this webinar. The first thing is why are we using Tizen, and why Tizen Common? How that project came in and why we did it. Secondly, we'll look at what we have been inheriting from Tizen Common, and how do we do the inheritance from Tizen Common in another project. We will follow by having a bit of a deeper look at what is provided by Tizen Common project. And we will conclude by looking at what have been our recent changes and additions to the project, what is coming for this new 2015, and if there is any questions, we will happily take a few. So let's start. Why have we done Tizen Common? For those who follow the public dev mailing list from Tizen, they had noticed about a year ago a project which started by Stefan called Tizen Generic, been renamed Tizen Common since, but the foundation remains the same. The challenge we had at the beginning of 2014 was that we realized that we would have to handle more and more profiles. When we started Tizen, and that is true for all Tizen 1 and Tizen 2 X product, we were originally very much focused on the phone, and then we looked at how we could have TV and cars. Reality has been a bit different. The first product to come out was actually a camera. The second one was a watch, and I don't know what's going to be the third one, but likely it's going to be a television or a TV, maybe a phone. But in reality, what we see is that we have significantly more profile to manage than it is reasonable to do if you have to do the maintenance from the individual profile. So in Tizen 2X, each profile has its own Git tree, and we try to synchronize after the fact. And that works on the paper, but in real world it's extremely difficult. So every people have been doing batches for their own product because they had their own need. And so resynchronizing is very difficult, which means that every time we want to add a new profile, we have to do that new work again. So with the increase of profiles, the creation of a common base was becoming critical, because we wanted to keep the compatibility between profiles. Compatibility really allows to get the value of Tizen. Tizen is focusing in the Internet of Things, as it's called now, on the connected object, but rather on the high-end side of the connected object. And which say connected objects actually talk about connectivity. So you need advanced connectivity. Because we have connectivity, we have security. As we're dealing with pretty private things like a phone, your photos, what you're watching on TVs, a watch which quite often is doing some work as a sensors for your health. We also have to manage privacy data protections. And because we are pretty high-end, we always have a sophisticated graphic to manage. And we wanted to keep the compatibility of that. That's a very important point. We also wanted to enable people to add application after the fact. That is one of the particularity of Tizen. And in order to add application after the fact, we need to have a common application development environment, which has to rely on some common base at the end to be able to work. So keeping compatibility was definitely critical. The second point was that we could not expect developers to have every available hardware. I know that a lot of hackers and enthusiasts, and I'm as guilty as numbers of them, will love to get the latest gadget, but we cannot have all of them. There's no way. And so we needed to find a way that people would be able to keep developing on the common part without being able to test on every single implementation of Tizen. And finally, we wanted to be able to get the work done by one profile when it is in a non-specific domain to benefit to the other profile. And for that, having a common base was also a very important topic. So with all these drivers, we realized that we needed to do a common base. And that common base is what is a project Tizen Common. Tizen Common is not a profile, it's not a product, it's actually a project which is providing a common ground for Tizen profile to derive from in order to make the life easy. So, ease of development was our initial drivers. We develop software. Tizen is a software project. But as we all know, and sometimes a bit of a pain, but that's real world, in order to run our software, we need some hardware. And in the embedded world, the challenge is always to have the reference development kit, especially on a project like Tizen, which is working on quite a lot of different architecture. So we have selected a number of reference hardware. So on the Intel side, we are supporting 32 and 64 bits. And we are a little bit privileged in that area because with Intel and the internal graphics system, the source for the graphic driver source is actually open source, 100% open source. So it makes it a little bit easier, I have to say. And so we could afford quite a large selection of product. Probably any laptop which is using the internal Intel graphics subsystem Gen X, which probably cover Ivy Bridge and higher, the NUC, on the industrial domain, the VTC 1010, which is based on a Bay Trail, and potentially even more interesting, the Minoboard Max, which is here listed for hackers, but actually is very interesting as well for industrial project, because this is an open hardware, which means that you can start with that board and modify it as much as you want in order to do exactly what you need. On the ARM side, the work of standardization has been done by a friend from Samsung, and they also provide 32-bit and 64-bit support. Unfortunately, as I speak today, I only have a reference platform for the 32-bit, which is the Odroid U3. But there are also on the ARM side a few other platforms which are supported by the community, the Olimax being one of those. Now you have to be aware that as graphic drivers are not open source in the ARM domain, if you have community supported, quite often you may have problem with the graphics subset by lacking the acceleration. The hardware acceleration is unlikely to be available. I'm not saying that this will never be solved, but for us in the open source side, something we cannot provide. It has to come from another side. I would also like to mention on the ARM side our friend from Renesas, which is a company specialized in that specific case for IVI systems, automotive and industrial. By extension, are also working very hard in order to support their system, and are planning to very soon provide a reference platform that will be capable to run Tizen 3, so Tizen Common, and Tizen AVI, because that's what they're focusing on their hardware platform. There are some activities that we have seen on a mailing list with people working on other architecture, like MIPS, for example, but we have not seen any images, and definitely on the Tizen Common project, we are not yet supporting them. If they progress, maybe it will come, but today it's definitely not done. So, with that, we enable an easy starting point. You just have to get your credit card, $100 roughly, sometimes more for industrial system, but still in a very reasonable domain, and off you go. You have the hardware which can run Tizen. So you're going to look at how you're going to work. Tizen, as I've said, is an integration point. It is not a profile, it's not a product. So you will still have to develop your own product on it. But what have we tried to do? Our idea was to provide a common base for most profiles. So the rule we started to apply was to say any package which is used by 2 profiles or more should actually be included in common. We also wanted that most of the packages which are in Tizen Common should be integrated in every single profile, and this is really to create this common base and having a very similar footprint for the basic functions. Obviously, we are still in the embedded world, and so we wanted to keep a very tight control on memory footprint and dependency. So we didn't want to drag things just because it was easy, because it might be needed one day, because it could flash an LEDs on that profile. So we wanted to be very strict in the way we are integrating things. And we're pretty proud of ourselves, but to be honest, there is always work to be done there, and this is a constant focus in the common project. Only add what is absolutely needed. So we see out of this small definition a little bit of a conflict. Tizen Common, in one way, we would like to get all Tizen Common in every profile. On the other side, we would like to have as common anything which is used in 2 profiles or more, and we have more than 2 profiles in Tizen. So that has forced us to define system of clarification or classification in common, which more or less can be cut in such a way. We have the part which is really the base, which is mandatory for every project. So every profile is going to include that base. Then we have what we want to share, and those are what we call the share tool, which typically are things which are used by a few profiles, and where we have the idea that if they are going to use it, then we would rather see them using the same package. And in those you're going to find some big middleware component, like the graphic subsystem, Qt, for example, or Qt as people call it, and EFL. But also complex submodule like Ophono. And we have a few ones which have not yet made it in that likely will come, like DLNA and Murphy. We have the other one on the other side, which are really base and mandatory, which the Linux kernel, the connectivity stack, and still today the HTML5 rendering. There is no profile without HTML5 yet. So we have a number of base stuff. So on top of that, we wanted to make the life very easy for integration. So we wanted to provide a system in the base, configured and tested for the part which is likely complex for an embedded company or an embedded team to deal with. Because that is at the edge between sophisticated desktop applications and traditional embedded, like managing multiple users, which is a quite important concept in certain profiles, like for example IVI, where the system is capable to provide different information to different people in the car and still has to isolate their privacy when connected to their phone. The security system, SMAC. For those who don't know, SMAC is one of the 3 backends of the LSM, the Linux security module, and in the desktop environment you're potentially more used to SE Linux or AppArmor, which are a little bit too complex and too heavy for embedded world. So SMAC is probably the browser for the small world of the embedded, but it uses exactly the same subsystem inside Linux. Cynara is a project which has been specifically developed for Tizen, and that's a quite innovative model, which is providing capability to do enforcement of applications privileges on the fly inside the middleware. It means that if an application is not allowed to do something, it will not be able to do it. And that's managed through Cynara. Obviously, you have a ripple effect in every single bit of the middleware in the OS after that. Crosswalk is the HTML5 rendering engine. It's our web runtime. It's based on Blink, which is also used in Chromium. So it's a very sophisticated and modern engine with quite good performance. And our default for the graphics subsystem is Western and Wayland, knowing that Western is really up to date with the XGG extension. We also have alternative where people can use X11 if they still want to do so. We have some profile which had a strong legacy that they didn't want to lose and were still attached to keep using X11. So that's an option. So this is an integration point. An important detail to remember is that Tizen Common, as I've said, is not a profile, but probably a helper. The compliance to Tizen is defined by profile. So Tizen Common is not compliant to anything as such. Your product in your profile will have to be compliant to the profile. So it will be your job to do that, and the profile compliances are mostly defined by the implementation of the correct APIs, which means that you could very well decide to derive from Tizen Common if you had good reason for doing so. It is your freedom. It could be very quickly becoming a nightmare, but you still have that freedom. So we wanted to be very clear on that point in the common project. We are trying to help you, but we don't force you to do things in one way. So, assuming that you are interested by what Tizen Common project can provide you and help you to speed up your profile product development, let's look what do we have in. Let's take one example. This is a mobile architecture. So the mobile architecture is based on the Linux standard. You have a set of middleware on which you have two application frameworks which are sitting. On one side, you have the web HTML5 application framework. On the other side, you have a native application framework, which is actually based on the EFL for the graphics subsystem. So that's what you have in mobile. Now, if we look at what is provided by Common, we can see that actually quite a big part is provided by Common. Most of the middleware, with the exception of messaging and telephony, which are actually shared. So we still provide them in common, but they are not mandatory. You have access to them. By default, we provide PIM evolutions, and telephony we have for now. We have seen we don't provide location and PIM. Sorry, I said PIM was, we have a messaging, which is part of the shared things, but not the PIM directly. And we provide all the HTML5 framework with the web UI, the web runtime, and the management of all the device APIs on top of the W3C standardized API. Why do we do that? It's just because in Tizen we believe that one very nice way to write applications which are capable to scale on different size of screen, which is typically what we have to deal with our profiles, is actually to write it in HTML5. It's a very powerful tool to manage that. It's also a tool which is known by quite a lot of people, so you have a standard environment. But you notice that in Common we do not support the native framework. That one is specific to mobile. Now, I will be honest with you, there is an action which is looking at providing a native framework during 2015 in Tizen Common. But today we don't have a public API, we only have private APIs, which fundamentally are the API from the Linux middleware and the Linux foundations. You will also notice that the kernel and the device driver are not directly provided by Common. And this is because we cannot really provide you your kernel and your device drivers for your hardware. We do provide it for our standard device, so the reference devices I was talking at the beginning. And we have organized the way we build the kernel for this reference device in a manner which is going to likely be easy for you to get a kernel which is compliant with the requirement of Tizen. With this requirement are probably for a modern Linux kernel with the security extension enabled. That's really where you have the big constraint on the kernel. So that's what is provided by Common. How do we split that? We have split the Common project in a few sub-projects. The first one is really the very much base you need to have, and that's what we call our Common Micro. It is typically what you're going to have to port on your hardware. You have your HAL, your kernel, your firmware. That is up to you to do. As I've said, we do provide that for all the reference hardware, and so if your hardware is derived from one of the reference hardware, which in the case of open hardware like the Minoboard Max is quite easy to do, you have a bit of an advance here. Otherwise, you're a bit by your own. We also provide the systemd, the PAM, the SMAC, all the links that we have in the way that we enable the Tizen to start up in a secured manner while remaining still low footprint and quick. We also provide you the base tool, which are going to be needed to create your distro and network connectivity. So that's fundamentally what you have. So when you have the Common Micro working, fundamentally everything which is dealing with a low-level plumbing is done. Likely you only have a black console with small white characters on it, and you can cry hooray and make a video and post it on the web saying, yes, I did it. But to be honest, when you have done that, you have done a lot, because after that, your command is going to work very quickly. So the next step is going to add Common Light. And Common Micro plus Common Light is actually creating your common base. And that includes the graphics subsystem Wayland, the HTML5, Crosswalk, all the middleware, and more connectivity through Bluetooth and the multimedia subsystem. So those have primarily quite light dependencies when you have done Common Micro. I would still like to point on the fact that you could have some optimization to be done in order to benefit from hardware accelerations if your hardware is not very much aligned with the reference hardware that we provide. Because as we know, depending on the chips that you have selected, you may have a very different hardware, and that one is, except in the case of Gen X, unlikely to be open source. So you will have to deal with it. But beside of that, when you've done that, you're done with Common. Now, we want to help you to go a little bit quicker, even further. The first part is by providing you the dev tool, so you can create your Common Micro and your Common Light in an easier way. And that includes the build tool chain, all the debug tool, the console tool, and even the test application, the QA tool, and the associated test suite. The QA tool and the test suite we do provide in Common are the ones that actually we use in the Common project and which allow us to do a run of automatic test every time we do a build. We call that a sanity test. But the main advantage is that the way they are packaged allow you to run them manually as well. You don't have to get any infrastructure to run this test. You can run them manually. And furthermore, the model is very simple. It's based on a standard open source project that many of you know, TestKit. you can actually add your own tests to it, and then you can benefit from the automations. We also provide some shared component. Would you like to go a little bit further than the common base? Alternative display system like X11, graphic toolkit like EFL and Qt5 that we keep up to date with the latest stable upstream, and that we actually optimize for the integration into Wayland. And we also have some complex middleware like Ophono, calendar subsystem, and as I've said, some other candidates are actually likely to join, especially the DLNA system with the DLNA project, and Murphy are, the one who are likely to get into the shared component. Today they are, to be honest, specific to the IVI project. So we know what is in common, we understand why it was done. Let's go to the real things. How do I do my project? It's actually very simple. You take the base, you have to do the HAL. If you use, as I've said, hardware which is based on a reference platform from Common or something very similar, that might be actually a non-issue. You take the dev tool and the QA tool, you pick up the shared component you like, and all of that already works. And then you add the specific from your profile on top of it. It is extremely simple. So, you will have your core packages, and those are the ones which are used in all the profiles, which means that they are going to move. They will have security update, they will have feature addition, so you will have to be ready for those to be moving. Some of them are actually very important because they provide, for example, the core API or the application framework or the security subsystem. You will have the shared packages, and on those one, it's nice to say synchronize, but it's definitely less critical. That will be a little bit of your call, but I would advise you to stay synchronized. And finally, the tools. We do provide a lot of tools with Tizen Common. It doesn't mean that you have to use them in your profile. It certainly doesn't mean that you have to put them in your image, in your product. You don't want them in your product. But we also have tools which are very specific to the common project, and that can confuse a little bit the people. For example, the kernel that we use, kernel common, is a kernel that we use on our reference hardware. So it's likely going to be a very little use for you directly, except if you use a hardware which is very similar to ours. The same for Western Common, it's optimized for our reference hardware. So we have a few things like that which are very specific. Now we have organized on the tool side what was very specific to our need for creating an image that you can use as test and as example in such a way that you could actually split out quite easily the part which is really the common part that you want in your profile from the part which is reasonably linked to the common demonstration, linked to the hardware used for that. I know it's a bit of a complex issue, and we will look at it a little bit later in the way, for example, we organize a kernel. So, you want to do your product. Common is not a product, but it provides you your base. So what you're going to have to do first, integrate Common. It has to work. You have to definitely enable a multi-architecture test, because if you have at any time to submit something of a change in Common, that will be one check that we will ask you. So at least on the base one, you want to do a check on, for example, ARM and Intel, and you may decide to run only one of those in emulation because it's not directly your problem. If you are convinced that you will never touch to any common stuff, you will just take it as it is, then you could actually ignore that step. And you will have to enable the synchronization for the key features. So you have to remember that we will work and we will change things in common because the world is not staying static. You have to remember that if you do any changes, or if we do any major changes, we will test them against common. That's a good habit. We don't do it directly on a profile. So if you have to do a test, you have to make a change, a big one that you're going to propose, and you believe it's going to touch a common component, then you have to test it against common. If you just come back to us and say, I tested that in my device, and it's really providing a useful value, it's unlikely to be accepted. We will ask you to test it against common. On the other side, when we do changes in Tizen, in the core of Tizen, we also test it against common. So a new version of Crosswalk, changing the compiler, making big update, that are things that we always test against common. Which mean two things. First, we are going to do the big changes there, so you don't have to do them. Let's take an example. We have to follow the upstream because we need to benefit from the bug correction and, for even more important, the security features which are added. For that, we actually synchronize our base packages against Yocto. Yocto 1.7 at the time of speaking. That is going to be tested in common. This can be sometimes very serious change with a lot of implication, which means that potentially Tizen Common could be broken sometimes for a few days. If it is going to be a little bit longer than 1 day or two, normally as a release engineer, who is Stefan today, will send a mail on the dev mailing list, warning people. On the opposite side, we do provide a Tizen Common image that we call daily, not because they come every day, but because they represent a day where it is working. And those are known to work, and so we would advise you to put your profile synchronization on these daily. They typically come about every few days. And we would advise you to do a synchronization very regularly against Tizen Common in your profile. Typically, every week is a good way of thinking. You remain master of your own integration pace. If at any time you decide not to integrate, you can. I just want to warn you that if you let the system go and you let run behind, likely the cost of reintegration is going to be horrendously high, and you could even be in a position where you cannot anymore do it, and then you have to bear all the cost of maintenance and update on security fixes by your own, which is definitely something that you don't want to do. How do we do the organization of the project, how we organize the project to make our life easy in synchronizing? If you see this graphic, we have two horizontal lines. The bottom one is common and the top one is your profile. Now, we're going to do submission on Tizen Common. And mostly it could be you, if you find something in Tizen Common that need changes. It could be the people who are working permanently on the common project. They do changes, and they're going to do a submission in common, only in common. It's going to be tested in common, and we're going to do daily. As I've said, every time it works, we do it daily. And on a weekly basis, assuming that you're going to do a synchronization. So you're going to pull that, which means that you're going to get a complete set of working packages organized together in your profile. Up to you to rebuild your profile with this new set of data. You can also do submissions which are going on your profile as well as on Tizen Common. That can be very interesting if you have made a bug fix. You found something, a bug in common, and you just want to correct it, and you want to correct it immediately in your profile as well. Then you can do a dual submission. You just have to remember that when you're going to do the next synchronizations, you will have to drop your own corrections because that will be probably already done in Common. And as I've said, you can do submission to your own specific profile. A profile always remains master of its own destiny. But if you start to make a lot of changes in Common, you're going to have to maintain them for quite a long time, which is likely a bad idea. Specifically on the kernel, because that is a very complex part to maintain. We decided in a meeting in April 2014 that we would synchronize on LTSI. The reason for choosing LTSI was that they definitely are maintained for quite a long time, and they are maintained by a set of industrial for consumer electronics and industrial visions, which means that not only we can put bug correction like in an LTS, but we can also add some feature backport in order to enable the LTSI kernel to be used for a longer period than an LTS, and to enable also support of new chipset would we like to do it. So that is a big flexibility that we have. Tizen 3, we have standardized on the kernel 3.14. Time of speaking, 3.14.20 is the one out. The LTSI has just been announced. It was actually announced during the Linux conference in Europe, in Düsseldorf, in October 2014. And the first image of LTSI was expecting any time now. So by the time you will hear that webinar, maybe it will have already been out if you take that webinar with a few weeks of delay against its publications. But our goal is definitely to add all the features which have been patched today in Tizen, which are not acceptable in the LTS because they are not bug fixed, but they are feature backport. We will push that into the LTSI in order to have to maintain as little as we can. Once again, if on your side you have patches which are of interest for the general industry, it is your entire interest to actually push them in the LTSIs as well, because otherwise you will have to maintain them. One thing I want to be very clear with is that Tizen is dealing with connected objects, so you cannot assume that you will stay on the same kernel for very long. Security requires to keep up to date your system. So even on an LTSI, you will have update coming on a very regular basis. So you need to organize yourself for that. And I advise you to visit the LTSI website to understand how the system is organized and how it can help you. On the kernel side, as I told you, we have a little bit of a dilemma here, because in Tizen Common, we provide things to be reused directly by profiles. But the kernel is very much linked to the hardware, and in Tizen Common we have to run on hardware which are reference hardware, which are quite wide. So we have enable options that you may not want to enable in your kernel. For example, we support on Intel architecture a lot of different hardware. So it works with most of laptops, as I've said, past from Ivy Bridge chipset and more recent, so Ivy Bridge or Bay Trails. Most of the iCore as well, the Core i5 and i7 will work. As long as they have a Gen X graphic subsystem, likely they work. So we have enabled a kernel which is pretty wide for that reason. We also wanted to work out of the box in the common test image with as many Wi-Fi subsystems that we could have, so people could have a USB stick. Problem is that they found out of a drawer and it should work most of the time. So you don't want that from us. So we have organized our configuration of a kernel in Common in really two parts in order for you to be able to have what is needed to run a Tizen project, and that's what we actually call the Linux stable. And we never built Linux stable, if you look in our building system, because we don't have a hardware running it. But that's the one you likely want to base from. You want to look at that. And we are going then to add a few things for common. So except if you have a common hardware which is very close to our reference hardware and you don't bother too much by having too many options activated, you don't want to copy directly the common configuration, but you rather want to copy the Linux stable and from there add your own patches. So that's one thing that definitely you want to look at. That detail is very well described on the wiki of Tizen Wiki. And if you look for wiki from Tizen and kernel inheritance model, all of those details are explained. If you have any questions, just send them on a mailing list and we will answer to them. Now, you have everything to build. You have to build. Now, you really have to select how do you want to build. And in Tizen, we offer you two methods for building. The traditional one, which was already used in Tizen 2, which is using an OBS. But because you do your own product, likely you don't want to publicly build it, so you're going to have to use a private OBS. Or you can use Yocto, and we have done quite a big work with the Yocto team in order to be able to support the build of Tizen with all the security feature inside Yocto. And that is now available from the base 1.7. We have a Tizen Meta, which is a Yocto compliant distribution, which will allow you to build common, and we even have a build for AVI, for profile AVI. So you have both options in front of you. Whichever option you take, you will have to do the same thing. You will have to take the base packages from common, decide which shared packages you want to add, define your hardware abstraction layers, add your profile-specific packages, and build. As it's shown in the image, depending on the fact you use a Git bitbake from Yocto or you use the OBS and the GBS front end, the model will be very different, but at the end you will get the same thing. So come immediately with that slide the question, which build system should I use? There is not a good answer to that, unfortunately. Both have a lot of pros and cons. Personally, I am one of those guys who've been working with an OBS for years and understand extremely well how it works and what are the benefits and disadvantages of that system. But I have to recognize as well that the numbers of people who are capable to set up a private OBS and to troubleshoot when it tend to not work like you would expect are likely a bit more than a handful in the world. You know, depending on who you talk to, you get the numbers between 20 and 50, which is very little. It's almost impossible to find any training, and the numbers of companies who can provide a real serious service on OBS are extremely reduced in the world. On the opposite side, Yocto is very, very well spread. And likely you already have engineers in your team who knows Yocto very well. Furthermore, if they don't know Yocto, at least the fundamental of the way you build is traditional from the embedded world. You know, if you've been using systems like Buildroot, yes, Yocto is very different and significantly more powerful, but the concept and the way you build and the process are not that different. So it's a bit easier to get in. So that's the big difference. OBS has a huge value when you have to manage multiple configurations, support legacy software builds, and just change a little bit. It will do miracle for you, but you have to know how to master the beast. So in a nutshell, if I would have to start a company today, privately, I would likely use Yocto because it's going to be easier to hire people and find the knowledge And if I'm in trouble, I will likely find a subcontracting company I can work with. If I would have a capability to get a big team and I would have to do tens of different products and maintain them with different versions for a long time, likely I will build an OBS and then I would have to train my own team. And I would have to isolate one or two skills guy to be my build master and share that for the entire company. So both options are very valid, and unfortunately there is not a right one. You will have to do your own choice. Now let's look at the use case, practical one. And this is the first project which was actually built on top of Common. It was Tizen AVI. We started at the end of 2013. Tizen AVI had done a release, and we wanted to activate the security. And we found out that activating the security was really a hellish exercise. Reason was that our friends from the mobile had succeeded to activate the security, but because at the time in Tizen 2 each profile were independent, the code base was very different. And so security being very intrusive, we could not apply security from our friend from mobile on the AVI system. We tried for several weeks without success. Finally, we decided to purely align Tizen AVI and Tizen Common. And to the nice surprise of all of us, it was actually pretty easy. And you can see it now today, it's available. Tizen AVI is maintained on Tizen.org. It's built using the OBS, public OBS, because we don't do a product as such, so we can afford to let everything in the public. If you look at the source packages, we have 752 source packages. Out of them, 691 are pulled directly from Tizen Common. Only 61 packages are specific. That is a very interesting relationship. You know, we get less than 1 out of 10 packages which are specific to the profile, which means that the people working on AVI only have to worry with AVI issue. Yes, they have to synchronize with Common on a very regular occasion. Typically they do it a little bit more than once a week. Every time we do it daily, and I've said it's about every few days. They have taken the Common kernel, so they are currently on 3.14.20, which means that they only have to maintain a different configuration than our Common image configuration, because they didn't want to have all the bell and whistle to work on all strange hardware that we wanted to do. You know, AVI didn't care to work on an old laptop which was available for test. They only wanted to work on an industrial product, which is a VTC 1010, and the MinoBoard Max, which are both based on Bay Trail, so they didn't need to deal with anything else for Intel. And for ARM, they probably only want to work on the Renesas chipset, so they can actually afford to have more tight control kernel. But because they share the same kernel with us, the job is significantly easier. As I've said, they synchronize their packages after every single daily that we do in Common, which is every few days. And obviously for them the benefit is huge. You know, instead of having to maintain 752 packages, they only have to maintain 61. And not only that, when they do the integration, they get a base which is working. So they don't really have to worry if the base is broken. Now, it doesn't mean that we provide them everything they want 100%, but at least they start from a working point every time we do a change. And that is a huge, huge benefit. So, after explaining you know, the why, the how, and roughly, you know, the system of reusing Common, let's look, you know, inside Tizen Common, you know, really how Tizen Common works. How do you create Tizen Common? You may not have to do it. You may, as I've said, use it as it is, but it could be likely that you will have to do a small change someday. And so it's interesting for you to understand how Tizen Common is controlled. So, as I've said, most of packages they actually pull from other profiles. Because if a profile starts to use a package and another one is interested, then they start to share it, and this is where Tizen Common say, hey guys, you're two using the same package, maybe with different versions. Let's put it in common. So that's how it happened. So that's the first way to get a package in common. And I've said we're already discussing with a candidate like DLNA or Murphy, which actually are candidates to enter in common because some people are interested, for example, to use Murphy for different things such as resource management. And if they do so, then we will pull it in. And that is publicly discussed on the public Dave mailing list, and once agreed, we move the package. So that really is a way to do it. For packages which are of interest but not yet used by profile, we get them first built in a home directory. Qt, for example, or Qt, has been a long time on the home directory of one of our friendly hackers, and when we had enough interest into it, we actually put it in the shared part of common. That the two ways to get into common. Now, obviously high acceptance criteria which are needed, because we want to be sure that the package which we'll get in common, then it will be built with every time we do a new image, and we will have to maintain it, and we'll have to guarantee that it works with a common base. So expect a little bit of a challenge before getting something into common. It has to be valued, and it has to be of a good quality. But when it's accepted, we have a very basic simple. So if people want the package to go into common, it has to probably follow 4 rules. The first one, it cannot break security, data integrity, multi-user mode, HTML5 support, and as soon as native support will become common, it will be added to the list as well. So any package has to respect that, and especially security and data integrity can sometimes be a little bit challenging, and so because some packages were not designed for that, especially coming from the embedded or even coming from the desktop, and so we had to do some changes to enable that or create extra layers on it to enable those facilities. We also want that every pre-release is going to be clean for all architecture. So typically 64-bit and 32-bit for ARM and for Intel. That's an important point. Quite often we had people who were just, providing things that would not build and run for an ARM, or will not build and work for 64-bit. That's not going to be accepted. If you are in common, it has to work for all the architecture and all the configurations. It means that the pre-release images will have to be building successfully. The pre-release images are created every time someone does a submission, and they're probably a quick check that the image is building with a new code. So you cannot let us down. If you get into common, it will have to be, clean for everyone. And finally, we want that the QA sanity test check pass on every pre-release images. So as you can see, the requirements are quite light in one way, but on the other side, they are pretty, strict. It has to work, not in every configuration for every hardware and so on, but it has at least to work with the 2 architectures and with the 2 model of compilations, and it has to work every time. Now, if your package you have submitted, let's say Qt, for example, sometime breaks because we have changed something in security, the common team will actually work, with you to help you to fix your package. We're not going to let you alone. But you have to realize that if you push something in common and you are the main user of it, you will have to work to get it to work for the common benefit, not only for yourself. The advantage of getting for you a package in common is that then you get more users, and it's pre-integrated every time, so you have an early advance facility to get the system working. Now, if you do that in common is maintained in the open source, it's maintained on Tizen.org, and today Tizen.org is built with OBS. We have discussion to actually build it with Yocto, but that is not publicly done yet. And so you will have to use GBS and submit for an architecture before that. So you will have to check with your different architectures that it does work. You have to submit to the right project. As I've said, you can submit only to your profile if you are doing a local corrections. Or you can submit to only Tizen Common if you submit a correction which is important for Common and for you, obviously, but that you can afford to wait a few days to see coming in, or you can submit to your profile and to Common. So you can also do a broadcast to all profiles, which typically is used for bug fixing. Considering some recent problem we had on the OBS, we might even consider to remove that facility to broadcast your profile in one go, because it has some side effect. An important point is that you may need to do group submissions. You have sometimes corrections or new feature which can only be tested and so will only create working image. And remember what I told you before, we will not accept your change if it doesn't work. You may want to actually tag a number of changes so they are tested together. If you change an API, you obviously need to change the client side and the server side at the same time, otherwise it doesn't work. So you want to do submission in a group model, and the tools allow that. As I've said, today is built on OBS. It could very well happen that in a few months, or maybe even shorter, we will build on Yocto first. That will not change. The model will remain exactly the same. You will have a tool to submit, and the submission will happen. At the end of the day, as I've said, we already manage both OBS and GBS, OBS and Tizen, and Yocto build in parallel. So the one which is used first doesn't matter. It's just the model will remain the same. So if you look at the OBS project for Tizen Common, you will find out that we get 830 source packages. To be honest, there are still a few that we believe we could remove out of that. You have different repository, 3 hardware architecture. I only talk from 2 today, ARM and Intel. There is a third one, which is the emulations, which is for the SDK, which is quite interesting to enable people developing external applications to work. And that just allows them to get an emulator working as well. And we have 2 flavors, WLAN and X11. So that's what we build currently. Why do we have 830 packages? Fundamentally because we have added quite a lot of test tools. And we also have some tools that we only use for our demonstrations. So when you load a Tizen Common image, you need to get a few things which are just working so you can check that it works. Out of those, you should expect to reuse about 600 of them for your own product, likely including development tools and test tool and test suite. That's about what you would expect. The Tizen base itself is about 300 packages. Tizen to Yocto already introduced the concept of using Yocto. I guess that a lot of you are going to be interested by that model because it's more traditional in the embedded world. I advise you just to go in the wiki on Tizen and to look at Tizen on Yocto. It supports its use a public dev mailing list, so you can have access to it. There's no problem. It's actually, as I've said, the Tizen on Yocto is a full distribution compliant with Yocto, which means that especially the BSP is separated, which means that you have the capability to, in a quite easy manner, change a BSP model if you had to do it. Now we also provide images which are ready to go, and that's quite nice if you just want to understand what is in Tizen Common. You don't even want to compile anything, you just want to run it. First, take one of our reference hardware. That's the first step. I have my personal preference for Middleboard Max because it's open hardware and everything is 100% open source, so I'm never locked out and it's available easily, but you can decide to use another one. Select which type of boot you are going to use, which type of architecture, and if you want to work in 32-bit or in 64-bit. You can also work directly in emulation mode, and then you only have it in 32-bit. Now, if you are working with an Intel hardware, there is an interesting model that we can use because we have the power of the BIOS. We have created an installer which is just a flash, a USB flash disk that you have to download and burn on a stick. And that can be with a legacy boot. Typically you want to test it in one laptop. And you can also do it with an EFI boot. And typically if you have a Mino board, that's what you will have to use. Once you boot from that USB stick, you will be capable to select first the language of your keyboard, so you can enter your Wi-Fi password. And then the system will download automatically the list of the available images, and you will select if you want a common or you want another profile, like IVI, for example, if you want a snapshot, a pre-release, a daily, a weekly, or an official release. My advice, if you want to test, take a daily release, okay? Because snapshot don't always works. So take a daily. A daily is a good bet to have the latest one, which is going to be quite hot and new, recently baked, but fully operational. So that about what is about Tizen Common. Now, let's look at what we've been doing in the recent months and what we are planning in the months to come. As you know, with open source, the concept of planning is always a little bit tricky, but at least recent history, we know what we have done. First, we have selected LTS, which is now LTSI, and we're very proud to have picked up the right one, so we did bet on the right horse by selecting 314. With all security subsystem. It's Max, but it's also all the integration of the latest systemd extension, so all the security system works. We have the latest Western, which was integrated. We have a very recent crosswalk, recent EFL and Qt, multi-user mode, and we have the security policy and the secured registry Buxton, which is an alternative to vconf, but which has a vconf backend for compatibility, but provide an extended security. And we have created snapshot and images for ARM. That was new. Before we didn't have that. We have supported as well as an option X11. We have enabled the emulator. And we have the installer image, which is what I was saying with our USB stick in the previous slide. And we even did a VMware player because we had a lot of industrial companies where they wanted to do tests without having taken any hardware, and let's be honest, they are working on Windows for many of them, and they have VMware player, so that was easy to do. Now, what are we planning to do, or at least hoping to do? Because what we do depends a lot on what you do. You know, the Tizen Common team is relying on the community. We are quite a number of professionals working on it, but we also have help from community. First, we have done, and that actually been done very recently, so you may have not even looked at it, which is a QC, which has the LTS 314 crosswalk, Welland, and a lot of things. We are also planning to do just at the end of the year, so when you will see that, will hear that webinar, likely it will be done. A release which has enabled ARM64, EFL as the latest, and Qt upgrade. A big change is that we have introduced the concept of user account management with GUMD, which allows us to manage accounts dynamically. It's a headless system, so you don't have any UI. And the security manager, that was one of the missing blocks for going to the next step of enforcing security and data privacy. And security manager is probably allowing us to reduce the privilege required by daemon essentially. So by network, by system services, we're going to reduce their capability. So if by one day, we would have a hacker who would succeed to break into one of the service of the OS service, that OS service would not have all the privileges. The privileges will be actually proxy to a more secure module, which is unique. Now, this is the end of my presentations, and while waiting for QA, I'll let you enjoy a photography of what you could see from the office where I'm working if you could fly at about 500 meters of altitude, watching towards the west. So as you can guess, it's a quite nice place when you like sailing. Okay, so first question. Should I stay tightly linked to Common? As I've said, yes, you should. You don't have to, but you definitely should. We have practical experience that I can share with you on the IVI project. When we did the first synchronizations, we introduced the security. And with the security, we had a lot of things which stopped to work. As you can expect, security is invasive, and when you activate it first time, probably your system goes to a halt. And so our colleagues from the RVI team, they probably work on their modules and probably let Tizen Common progress for about a month and a half. It's not very long, but resynchronizing proved to be extremely painful. Because then what happens is that you have a lot of subsystem which breaks and you don't know which one has broken. And so tracking the guilty one becomes very difficult. So my advice is definitely stay very tightly linked. Now, you don't have to synchronize every day. I would say a weekly base is likely a good compromise between having a little bit of stability for your teams and progressing. And in that point, if you're using an OBS, the OBS is very good at building that type of things. Now, if you use Yocto, you have to enforce the people to keep in sync. So that advantage or disadvantage of Yocto, where people work independently. But my advice, definitely stay tightly linked, and letting shift for more than a week is likely a bad idea. Second question is, should I use Yocto or OBS? I have made already an explanation on that. It's a question that I have almost every single time I do a presentation of Tizen Common. There is not a right answer, but if you come from the embedded, you likely want to use Yocto. So if you do not have to maintain for a very long time multiple versions of your product, but you rather do images where you actually recreate a new software and you push that, you likely want to use Yocto. It will be easier to hire people. It will be easier to motivate people. It will be easier to create your infrastructure because probably every PC is doing its own build. You will still have to build a build boat for your QA team if you want to automate that, but you don't even have to. It's actually easier to start, and Yocto grows very well. It's not for any reason that it's so successful in the embedded Linux world. It works very fine. But if you know that you're going to have to maintain a large numbers of product with multiple versions, different hardwares, but you want to get some common part of middleware because you have some common API you want to keep up, then the OBS is a fantastic tool to do that. But otherwise, yeah, likely you want to use Yocto. Interesting. Should I still run QA? Do I have to run a QA? I understand that. People look at example of IVI I gave where less than 10% of the packages are actually specific. And so, do I have to do a full QA, or just can I afford to QA only my bit? Unfortunately, no. You have to run your full QA. And there are two reasons for that. The first one is that us, in the Tizen Common project, we do not provide a product, we provide an integration point. So what we do is that we integrate and we make work together a few hundreds of packages which are evolving about every day. So we follow these evolutions, we make the security works in it, but we don't test it as a product. So that's the first step. So we have sanity check, and we know that when you're going to take a daily, it's not going to be broken. But we cannot guarantee that it works in the use that you have of that middleware. So you have to check that. The second reason is that we don't test on your hardware and in your configuration. We test on a few reference hardware, and that's it. But you can always have race conditions. You can have some strange effect with, especially with different speed, with different multi-threading and multiple core running in parallel. So you have to test that. So don't expect us to provide a ready-made package which is, guaranteed to work everywhere in every case. No, we provide an integration point. We make your life easy, but unfortunately, you still have the responsibility of testing your entire product. So you have to plan for a full QA. That's definitely an important point. On this, having no more questions? No, okay. I wish you a nice continuation of your day, and as I've said, I repeat, if you want more information, you will find it in the tizen.org, especially on the wiki, on wiki.tizen.org. And from there, you can track our mailing list, especially our public Dave mailing list, or the mailing list specialized by profiles. I wish you a nice day, and hope to talk to you one day on the mailing list on our RRC, or in one of the conferences where we will present what we do.